Hello everyone, welcome to my channel Physics Tricks. So let's start with the magnetic effect of electric current problems, and in this we have the first problem. An arc of circular wire subtends an angle 60° at the center given. A total current of I ampere is sent through a wire attached to one end of a circular wire as shown in the figure. We want, if radius of circular wire is 2 centimeter and the current is 2 ampere flows through, then magnetic field induction at the center we want. Okay, so see here, if we have the current carrying circular coil supposed to be like this, from the one end if it carries a current of I ampere, and in the other end we have the same current I, and at the center it makes an angle of 60°, then we can calculate what is the current in this I1 and what is the current in this I2. So to find current I1, what we have to do is take total current, multiply it with opposite resistance divided by total resistance R1 plus R2. Now to find R1 and R2, resistance R1 and resistance R2, we have to use R1 is equal to theta by 360 into the total resistance capital R. So what is the theta over here? 60° divided by 360, so which is equal to R divided by 6 ohm we have R1. Likewise, what is R2 then? R2 we have is, R is R1 plus R2 we can say, isn't it? Total resistance. So R minus R by 6 will be the R2, that is 5R by 6, or else 300 divided by 360 into R will be the R2, that is totally fine. Okay, so R1 and R2 we got. So what is I1 then? I1 we have is IR2. R2 we have is 5R divided by 6 divided by total resistance R get cancelled, we'll get 5I divided by 6. Likewise, what is I2 then? I2 we can write I minus of I1, which is I in bracket 1 minus 5 by 6, which is I divided by 6. So I1 we got, and that is 5I divided by 6, and I2 we got, and that is I divided by 6. Once we got the current in the bottom wire and the up wire, can we calculate the magnetic field at this point? So firstly, for that, find out the direction. See, due to I1 is clockwise. I1 is clockwise. The thumb is pointing inward. That means due to I1 at the center, magnetic field is into, so V1. Now I2 is anti-clockwise. Anti-clockwise like this. Anti-clockwise like this. This thumb is pointing towards you. Indicates out of the plane. Out of the plane. That is B2. Okay. Now what is B1 magnitude? B net we have is, firstly B net is B1 plus B2. As the direction is opposite, we can write B1 minus B2. This negative sign indicates what? If one is positive, if you consider, other one must be negative. Okay. So B net is equal to, what is the magnetic field due to circular arc? Formula is mu naught I divided by 4 pi R is the radius, into theta, right now, minus mu naught I divided by 4 pi R dash into theta dash. Okay, so over here this is I dash only. For the first conductor, I is for the first one we have I is 5I divided by 6 divided by 4 pi. Radius is R only, and theta we have is 60, that is pi divided by 3, minus mu naught, what is I in the second conductor? I by 6 divided by 4 pi, what is R dash? Radius will be the same, into theta dash we have is 5 pi divided by 3. And as you can see over here, this is mu naught I divided by 6, 4 pi r, 5 pi by 3, mu naught I divided by 6, 4 pi r, 5 pi by 3. Same thing, no? So this will become 0 Tesla. So whatever first option is given, that is correct. Now due to what is called as the same 2 centimeter radius and magnetic field induction at the EDB we want. Okay, EDB we want. So therefore, magnetic field at ADB, that is due to the upper part or lower? Yes, lower part we want. A, this is D, this is B, as you can see over here, right? This is A, this is D, this is B. Okay, so we have magnetic field due to ADB is equal to mu naught I2 divided by 4 pi r into theta. So which is equal to mu naught, what is I2? It is I by 6 divided by 4 pi r into theta we have is 5 pi by 3, that is 300 now. So pi get cancelled, pi get cancelled. So magnetic field due to ADB is equal to mu naught I divided by, this is 5 over here, this is 6 into 4 into 3 into what is r? It is 2 into 10 to the power minus 2. So which is equal to this is 500 mu naught I divided by, this is 18 into 4. So what is 4 1s are 4 2s are 4 5s are. So it will be 125 mu naught I divided by 18, indicates magnetic field due to ADB is 125 mu naught divided by 18. So B is also correct, and we know that ADB and ACB both are same, so it must be the same, and D not possible. So what is the answer for this? It is A comma B comma C. So these are the correct options for the given question. This is the second question now. In an n-sided regular polygon, the distance from center of polygon to each vertex is A and the length of each side is L. Then answer the following. We have to find firstly magnetic field value at the center of polygon. Okay. So firstly we'll calculate what is the magnetic field value at the center of the polygon. So this is the polygon given, which carries a current I, and at the center here we want what is the magnetic field value. So this is the finite current carrying conductor. We can say each side will be the finite current carrying conductor. If I drop a perpendicular on it, this is alpha supposed to be, and this is beta supposed to be, and this is D perpendicular. This side is given A and this is given L by 2. So what is D perpendicular over here? D perpendicular we have is root of A squared minus L squared by 4. What is alpha and beta? They are equal. What is the value? How to find? See, for n sides angle will be 2 pi. For n sides angle will be 2 pi. For one side what is the angle? It is 2 pi by n, and then we have to divide this into two parts, that is pi by n. So I hope this is clear, right? So see, for n sides angle we have is 2 pi. For one side angle will be 2 pi by n. Therefore this 2 pi by n we have to divide into two parts. No, this total is 2 pi by n. This total is 2 pi by n. So divide it into two parts. Why? Because alpha and beta are same. This is L by 2 and this is L by 2. Alpha and beta are same. So it is pi by n. So therefore put in the formula, magnetic field is equal to mu naught I divided by, it is 4 pi d perpendicular into sine alpha plus sine beta. Now which is equal to mu naught I divided by 4 pi. What is d perpendicular over here? It is root of A squared minus L squared by 4 into what is sine alpha and what is sine beta? It is 2 sine pi by n we have. Okay, now this 2 and this 2 will get cancelled and we'll have mu naught I sine pi by n divided by 2 pi root of A squared minus L squared by 4. Now this is due to the single conductor. Likewise n conductors are there. So for n side we have the magnetic field, net magnetic field at the center is n times mu naught I sine pi by n divided by 2 pi root of A squared minus L squared by 4. Now check the options. It is given in option C. So that is the answer. Now next one, what will be the magnetic field value at the center if infinite number of sides are there in polygon? Now infinite number of sides are there, then what will happen? then what will happen? That is what we have to see over here. So in that case, okay, we have what is called as the for infinite side, we have bnet is equal to mu naught I divided by 2 root of a square minus L square by 4 into sine pi divided by n divided by pi by n, right? So this is the n tending towards infinity we have, right? N is tending towards infinity. So if n is tending towards infinity, then what we have to do? Bnet is equal to mu naught I divided by 2 root of a square minus L square by 4 into limit n is tending towards infinity sine pi by n divided by pi by n. This has a value 1, and we have bnet is equal to mu naught I divided by 2 root of a square minus L square divided by 4. Now see, mu naught I divided by 2 root of a square minus L square divided by 4, and that is given okay. So L is tending towards what then? If we have infinite number of sides, then L will tend towards this, A will become radius and L will become 0. So if you put L is equal to 0 over here, you will get mu naught I divided by 2 into A, and that is what for the circle we have. But over here, if I put L is equal to 0 over here, then I'll get this pi get cancelled, mu naught I divided by 2A, so this is possible. Pi is there, so this is not possible, this is not possible, and this is also not possible because L is equal to 0. If I put mu naught I divided by 4A, we are getting. So this is correct, but here L square by 4 minus, A square minus L square by 4 is there, but L is either way 0. So you can consider L as positive or negative, that is totally your choice, because with 0, if you consider 0 positive or 0 negative, you will get the same answer. So for this, B is the correct option, we can say that, right? Chalo. So next question number 3. In this question it is given, equal currents are flowing in 4 infinitely long wires. Distance between 2 wires is same and direction of currents are shown in the figure. Match the following 2 columns. Okay. Force on wire 1. Force on wire 1 is equal to what? So due to this conductor, it is inside magnetic field. Due to this conductor, it is outside magnetic field, and due to this conductor, it is inside magnetic field. Okay. So due to this conductor, inside magnetic field indicates what? The magnetic force will be in this direction, that is repulsion. Due to this one, we have attraction. Due to this one, we have repulsion. It is leftwards, we can say. Then force on wire 2. So first one we have Q. Then force on wire 2, this one. We'll check for 2. See, for 2, due to this, the magnetic field is outside. Due to this, magnetic field is inside. These two will cancel out each other, so 0 magnetic field. Due to this and this, they'll attract. So it is rightward. it is R. Then force on wire 3, force on wire 3. Okay, so due to second wire it is outside magnetic field. Due to fourth wire it is inside magnetic field. They will cancel out each other. So it is a rightward only. Force on wire 4. Force on wire 4. It is due to this it is inside. Due to this it is outside magnetic field. Due to this we have inside magnetic field. So both these two will contribute to repulsion, so rightward only. So it is Q triple R will be the answer, we can say, right? Chalo, next question number 4. In this, from the given figure, answer the following. Current of magnitude I is following. Okay, so what will be the magnitude of field due to portion of wire QR and ST at the center? See, QR is lying exactly on the center, we can say. It is along the line. So whenever along the line is given, it is 0. What will be the magnetic field at the center C due to entire wire? So QR will not contribute, ST will not contribute. It is only the this and this will contribute. You know? Okay, so just the direction we have to see. It is outside due to circular wire. It is outside due to circular wire, and it is inside due to the straight current carrying wire. So it is negative sign that we want. So negative is given everywhere. Let's see. So B net we have is equal to B due to straight wire plus B due to circular wire. It is twice the B due to straight wire because it is semi-infinite. So at a distance of A plus R, it will be the same. So 2 mu naught I divided by, it is 2 pi, it is 4 pi R because semi-infinite. 4 pi R is A plus R plus B due to circular wire is mu naught I divided by 4 R, and R is small over here. Now here Y positive, here we have to consider 1 is in the negative direction. Why? Because the direction is opposite. So if you take mu naught I divided by 4 common, you will get this is equal to 2 divided by pi of A plus R minus 1 divided by 4. And that is R. 1 divided by 4 R. So, sorry, why 4? It is R only, na? Yeah, because 4 we took common. So 2 divided by pi A plus R minus 1 by R. If you take pi common, you will get mu naught I divided by 4 pi in bracket 2 by A plus R minus pi divided by R. So that is the answer, and it is given in option B. And the last question we have, fifth one. Each of the lettered points at the corners of a cube in figure represent the positive charge of cube moving with velocity of magnitude V. The direction is indicated. The direction of uniform magnetic field is parallel to the x-axis directed toward the right. Then we want the force on charge at D. Okay. So this is the diagram given. At D, as in this charge is moving in this direction at an angle of 45 degree, exactly bisector we can say. So with respect to x-axis, it is making an angle of 45 degree, and along the x-axis magnetic field B is there. So this velocity V. So the force we have is V bar. Along V bar you have to stretch the fingers, curl it towards V bar. This thumb is pointing in the downward direction. They gave this as Y. So downward indicates minus J. So force on the charge which is placed at D is equal to QVP sine theta into the n hat. So whatever the unit vector is there. So QVB sine 45 is 1 by root 2 into n hat as in minus j hat. So we have answer is QVB by root 2 into minus j hat. So minus QVB by root 2 into j hat, it is S. Likewise, force on charge at C. Force on charge at C. charge at C, what is the angle between the x-axis and the C velocity of the charge? So it is, this is the C, right? It is moving in this direction, and along the x-axis, what is the angle? So angle is 180 degree. So force on it will be 0 Newton. So whenever angle is 0 degree or 180 degree, angle force will be 0 Newton. That is R. So the force on charge at B, so velocity is in this direction, that is along the z-axis, and the angle between the x and z-axis, we know that it is 90 degree. So it is V bar, cross V bar, if you do, it is along z hat. So it is QVB along z hat. And answer for this is Q. Last one, the force on charge at A. At A is moving in the upward direction, so this is moving in the upward direction, so velocity is V. So V bar cross B bar, it is minus K hat. So minus K hat is given in the P. So it is SRQP will be the answer for this fifth question. So I hope this is clear to you all. Now if anyone has any doubt, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.